Yes, dear students, today we are going to see about in this session relation between current and drift velocity. So current we know that I, drift velocity is a Vd. What is the relation between them? So let us assume that there is a wire with the area of cross section A. It is connected with the battery and the key and it is given. So the direction of the electron flow is this direction, negative to positive, and the current direction is this direction. When the battery switch on, the randomly moving free electrons are drifted towards one particular direction. That velocity is called as a drift velocity. The length L is the length of the wire, A is the area of cross section, and N is the number of electrons in the given wire. So as a charge in electrostatics, we say that current means Q by T. So first, what is the Q? Q is a charge which is equal to Ne. But this is in electrostatics. When the charges are flowing in any material, we have to consider this volume, that is the area of cross section, and length L. If the length increases, number of charges increases. If the area of cross section increases, number of charges increases. That we have put that instead of N, NaL into charge E. So for wire we have to substitute Q is equal to charge is equal to NaL into E. N is the number of electrons, A is the area of cross section, L is the length of the wire, and E is the charge of the electron. Then time. So how we can calculate the time? The current flow per unit time. So drift velocity which is equal to distance by time. The distance traveled by the electron is L distance and the time taken is T. So you bring the T this side and Vd here. So L by Vd. So substitute this T and Q in current I is equal to Q by T. We get NaL by L into Vd. So this L comes denominator and Vd comes to the numerator and LL get cancelled, and finally we arrive the expression for relation between current and drift velocity is equal to I is equal to NGAVd. So this is a scalar form relation between the current and drift velocity. If you bring this area in the denominator, what is that? I by A. So I by A, I divided by A, which is equal to NGVD. So again I will show you NGAVD. You bring this A in the denominator, we have only NGVD in the right side and A in the denominator of the left side. So I by A is a current density. So current density J is a vector, Ne, and drift velocity is a vector. This is a vector form of relation between current and drift velocity. This is a scalar form of relation between current and drift velocity. Then we are going to derive that what is the relation between the resistivity, current density, and collision time. Resistivity in terms of current density and collision time. So the electric force given in this experiment is F is equal to E. E is an electron, so we have to put minus here. So F is equal to minus E. So when the electric force is given, what will happen? The electron of mass m will be drifted and moves with the velocity Vd. There is a rate of change of velocity is called as acceleration. So the electron has an acceleration. It will obey the Newton's second law, but in microscopic the Newton's second law is not obeying. For derivation purpose, we are taking that Newton's second law is equal to F is equal to ma. So this force is an electric force. This is by observing this force, the electron will obey this equation, Newton's second law equation, F is equal to ma. So ma, which is equal to minus E, that is E is a charge and capital E is an electric field. So bring the m in the denominator. Acceleration of an electron, free electron, is equal to minus E by m. So acceleration which is equal to drift velocity by time. Drift velocity is a Vd and time is a collision time. So Vd by tau is equal to E by m. Bring this tau here. So the expression for drift velocity is minus E tau by m, where the negative sign indicates that the charge of the free electron. So this is the expression for resistivity in terms of J, and we have to continue in the next page. Yes, dear students, the relation between the current density J is equal to NeVd, and we have to substitute this second equation Vd. You have to substitute this Vd in this first equation. So the current density J is equal to Ne, Vd value is E tau by M. Then what will happen? Ne square tau by M into E. So J vector, which is equal to some quantities Ne square tau by M into electric field E vector. We already know that the vector form of Ohm's law is equal to J is equal to sigma E. So J is a current density, E is a electric field, both are vector, and sigma is a conductivity of the material. So comparing these two equations, so what will happen? J and E. So then the conductivity must be equal to Ne squared tau by M. So the conductivity and resistivity are reciprocal to each other. Then resistivity is equal to rho is equal to M by Ne squared by tau. So this is the relation between the resistivity and the tau with the current density J value. Dear students, I will show these pages for your copying in your classwork note very slowly. The relation between the current and drift velocity. First we calculate the charge and time, substitute in current, then we will get the scalar form of relation I is equal to NEA Vd. Then we get the vector form of current density and drift velocity relation. By continuing that, we are calculating that resistivity in terms of current density and tau. So very simple equation. The electric force will become a Newton's second law. By giving a electric force F is equal to E, then the electron obeys with the Newton's second law F is equal to ma. By substituting these values, we arrive the drift velocity, which is equal to E tau by m. So continuing this with the previous page. So we derive the expression for resistivity. Yes, okay. Now we move to that. What is the cause for resistance, sir? So this topic we are already studying in 10th standard. I will recall you. So what will happen when the material is connected with the potential difference positive and negative, that is a battery. So the actual path of the free electron is a straight line. But what will happen actually? So when the potential difference is applied, the expected path of the free electron is straight line. But actually what happens means, if this free electron is a negative charge and ion is a positive charge, there will be electrostatic force of attraction. That means Coulomb force of attraction between this positive ion and the negative electron. So the negative electron will move this side. But what will happen at this time? This positive terminal, this potential difference force is higher than this force of attraction. So the electron will again comes to the original position and move in the straight line. Again it will move towards a negative, this downward direction with the positive ion. Then the force of attraction between this positive ion and the free electron is less than the force of attraction between the positive terminal of the battery. That is a force, attractive force given by the battery with the free electron. So again the free electron will move that. So very clearly I will say that the electrostatic attraction between the free electrons and ions will reduce the flow of electrons, will slow down the speed of the electrons. Similarly, some free electrons may collide with the other free electrons. There is a free electron, B free electron. These two will collide with each other and it will scatter with each other. Again the B will collide with the another electron and A will collide with the another free electron. So these collisions also slow down the motion of free electrons. Hence the collision between the free electrons and the ions, collision between the electrostatic force of attraction between the free electron and the ions. These two phenomena makes the free electron to move slower. That means it retards, it slows down the flow of free electrons. This is the cause for resistance. This property of the wire, this arises in the material itself. We cannot avoid this process because whenever the free electrons are formed, there will be availability of the positive ions, there will be availability of the other free electrons also. The collisions also inevitable and the electrostatic Coulomb force of attraction between these two also inevitable. Hence the electron flow will be slowed down by the property of the material. Hence we say that the resistance is an inherent property of the material. So this is the cause for resistance in a material. Yes, students, I will show this page slowly in order to copy in your classwork note. Dear students, since in the Ohm's law itself I saw that the temperature will be depend upon the resistance or resistivity of the material. So now we are going to see that what is how the temperature will be depend on it. So that the resistance or resistivity is directly proportional to temperature for your metals. So for a metal, the resistance or resistivity is directly proportional to temperature. So in such a cases, we can write the expression, we can express this resistivity in terms of temperature like this. So rho is the resistivity at temperature T. Rho naught is the resistivity of the material at temperature T naught. So that is the same material, but the resistivity will be changed. At 0 Kelvin, the resistivity is rho naught. At a particular temperature T is equal to 300 Kelvin or 500 Kelvin or 200 Kelvin, the resistivity is rho. So rho is equal to rho naught into 1 plus alpha is the proportional constant temperature coefficient of resistivity into the difference between the temperatures. That is the final temperature minus the absolute temperature 0 Kelvin. So the 0 Kelvin T naught is a 0 Kelvin is a absolute Kelvin. So the resistivity at 0 Kelvin and the resistivity at the temperature can be related as follows. If you bring the resistivity here and there, and finally we arrive the expression alpha is equal to 1 by rho d rho by dt, where d rho is a small change in resistivity, difference between the resistivity at temperature T and resistivity at temperature T is equal to 0 Kelvin, and dt means a difference in temperature, these two things. So this is the expression. Similarly, we can write the expression for in terms of resistance. R is equal to R naught 1 plus alpha dt. dt is the difference in temperature, and we can represent that alpha is equal to R minus R naught by R naught into dt. So dr by dt which is equal to 1 by rho. So it is a mere expression. We should know that. So what is the expression between the temperature and resistance and resistivity? So we often say that there are the two types of temperature coefficient of resistivity or the resistance alpha. So it is a positive and negative. When it is a metal, these two are directly proportional to temperature, means it is a positive temperature coefficient of resistance. The temperature and the resistance or temperature and resistivity are directly proportional means positive. It is inversely proportional means negative. So this will be happens in the semiconductor. So the semiconductor lesson we are going to see in the last chapter of our plus 2 class. So that T is equal to 0 Kelvin, absolute Kelvin. So the material, certain material will act as an insulator. When the temperature increases to room temperature, that the same material will act as a conductor. Here the free electrons are not available. Here the free electrons are available in the material. This type of the material comes under the category of a negative temperature coefficient of resistance. The temperature and resistance are inversely proportional. Dear students, so I will show you very clearly for the copying in your classwork note. I hope up to this, whatever the things we are seeing in the previous 3 session videos are simply, it is a mere introduction to current electricity.